Hey everyone, welcome back to the channel. In today's video, we're diving into a super important and often misunderstood method in JPA. What does EntityManager.flush actually do? And more importantly, when should you manually call flush? We've all seen this method around, but most developers either avoid it or misuse it. So today we're going to break it down step by step with simple examples, clear console logs, and real-world explanations. So even if you're a complete beginner, by the end of this video, you'll feel confident using flush in your code and know exactly when to use it and when not to. Alright, let's break it down in simple terms. So what does EntityManager.flush actually do? When you make changes to an entity, like saving a new employee, updating a name, or deleting a record, JPA doesn't immediately send those changes to the database. Instead, it keeps those changes in memory, inside what we call the persistence context, kind of like a temporary workspace. Now here's the key point. When you call flush, you're telling the entity manager, hey, go ahead and push all the pending changes in memory to the database, right now. That means insert queries, update queries, delete queries, all get executed immediately, even if the transaction hasn't committed yet. But remember, flush does not commit the transaction. So the data is pushed to the DB, but it's not permanent until you commit. Alright, let's now talk about the benefits of calling flush manually, and why sometimes letting JPA handle it automatically just isn't enough. When you call flush, you're basically telling JPA, hey JPA, stop holding on to those changes, push all the pending inserts, updates, and deletes to the database right now. Normally, JPA waits until the end of the transaction or when a query is executed before it actually hits the database. So your changes just sit in memory, not yet visible to the DB. But with flush, the SQL statements are executed immediately, even before the transaction commits. Let's say you just saved an employee record, and now you want to use that same employee's auto-generated ID in a native SQL query or for logging. Without flush, that record might not yet exist in the DB, so your query could return wrong or incomplete data. But by calling flush, you're forcing that record to be written to the DB instantly, so your next operation sees the latest data. So in short, use flush when you need the database to be fully up to date right now, not eventually. Next up, let's talk about control over persistence timing, one of the most powerful reasons to use flush. Imagine this situation. You just updated or inserted some data using JPA. And now you're about to run a native SQL query or maybe a read operation that depends on that updated data. Now here's the catch. JPA doesn't immediately push those changes to the database. It waits until the transaction commits or a query forces a flush. So if you run your read/query without flushing, you might get stale or incomplete data. Just call flush before the next operation. This guarantees that the database is fully in sync with your recent changes before the next step runs. This is especially useful when working with native queries, stored procedures, immediate validations, or anytime you want precise control over when things hit the DB. Now let's talk about another super helpful benefit of using flush: early detection of database constraints. Let's say your database table has constraints like not null, fields that must have a value, unique, like email or username, foreign key, references to another table. Normally, JPA waits until the end of the transaction, commit time, to push changes to the database. But here's the problem. If something is wrong, say a null in a not null field, you won't find out until commit, which might be several steps later. That's bad for debugging and can cause more complex rollbacks. Alright, let's look at another important use case for flush. Improves consistency in complex logic. Sometimes in real-world applications, you don't just save one thing and stop. You might have a chain of actions inside a single transaction, like insert a new employee, update their department record, trigger some audit or validation logic based on the inserted data. Now here's the issue. If you haven't flushed the changes to the DB yet, those subsequent operations might work on outdated or incomplete data. But by calling flush between the steps, you make sure that intermediate changes are actually saved. Any following logic works on the latest, consistent state. You avoid weird bugs caused by working with stale data. In batch jobs or loops updating hundreds or thousands of records, Memory usage can spike because Hibernate stores all managed entities. By periodically calling flush, you push changes to the DB. Free up memory. Avoid memory leaks or out-of-memory error. Alright, we've seen some great use cases for flush, but now let's flip the coin and talk about something equally important. When should you not use flush? Because yes, while it's powerful, misusing it can actually cause more harm than good. So listen carefully. Don't use flush unnecessarily. JPA already knows when to flush. Before committing a transaction or before running a query. So, if you don't have a strong reason to flush early, don't do it. It just adds extra database load for no real benefit. Next, avoid using flush inside tight loops unless you're managing memory carefully. If you're saving thousands of records in a loop and calling flush every time, that's going to slow down performance and clog up your persistence context. Better way? Use flush, along with clear, in batches, keeps memory clean and DB interactions optimized. Don't confuse flush with commit. Let's be super clear here. Flush only sends SQL to the database, it doesn't commit the transaction. So, the data can still be rolled back if something fails later. Okay, let's get started with the hands-on part. Now take a look, we've already got two important methods here, save employee, where we're using persist. Update employee, where we're using merge. Before we test anything, let's do one quick thing. Add some logs inside both methods, so we can easily see in the console when these methods are being called and what's happening. Okay, right above the persist call, let's add a simple log statement. This will make it easy to track in the console, especially when we want to match the log with the exact SQL insert query generated by JPA. Great! Now that we've added a log before calling persist, let's also add one right after the call, so we can clearly see when it completes. Alright, before we move ahead, let's do a quick cleanup. I'm going to remove all the commented out code from this file, just to keep things clean and readable. Okay, just like we did with persist, let's add a log right before calling the merge method inside update employee. So here's what I'm doing, follow along. Perfect. Now let's add a log right after the merge call so we can clearly see when it completes. Start the application. Next hit the Add Employee API. This is the one that calls the Save Employee method internally, where we used persist. We got a successful response from the API. Important note, let's clear up a common issue that you might run into here. If you see an error like this, detached entity passed to persist. Don't panic. This usually happens when JPA thinks you're trying to persist an entity that already has an ID, which it's not supposed to do. In our last video, we changed the employee ID field in the entity to long, the wrapper class, not the primitive long. But our DTO still uses primitive long, so when no ID is provided, it defaults to 0. The problem? When you call the API, 0 gets passed to the entity, and JPA thinks, wait, this entity already has an ID, but you're trying to persist it? Sounds like a detached entity. And boom, you get that error. So, here are two simple ways to fix it. Option 1. Update your DTO to use long instead of long, so you can properly pass null when creating a new employee. Option 2. In your addEmployee method inside the service class, just check for 0 and set it to null manually. That way, JPA knows this is a new record, and it won't throw the detached entity error. Alright, remember a few minutes ago we called the addEmployee API? Let's go back and open the console logs to understand what really happened under the hood. First, we can clearly see the log. Employee Entity Manager repository.saveEmployee, calling EntityManager.persist. Then, immediately after, there's the SQL insert query. And finally, the log. Employee Entity Manager repository.saveEmployee, completed EntityManager.persist. So what does this tell us? It means JPA fired the insert query right away, even before we committed the transaction. But why? Here's the catch. Alright, so in our employee entity, we're using generationType.identity for the primary key. What does that mean? It means the database is responsible for generating the ID, and it does that at the time of the insert. So as soon as we call EntityManager.persist, JPA immediately executes the insert query, because it needs the generated ID back from the database. In this case, JPA has no choice but to fire the insert immediately, because it needs the ID back from the DB. That's why the query runs as soon as persist is called. Now let's do an experiment, do exactly what I'm doing. In the employee entity, create a new field called Employee ID1. And mark the existing Employee ID field as a transient. By doing this, we're telling JPA to completely ignore this field. It won't be mapped to any database column. So even if we set a value here in code, it won't be saved to the database. Let's make Employee ID1 field a UUID-based ID. What we're doing here is shifting from a DB-generated numeric ID to a UUID, which JPA can generate without needing to hit the database immediately. Start the application. Hit the addEmployee API again. We got a data truncated error. But hey, no worries. We're not going to fix this error right now because the main goal of this experiment was not to insert successfully, but to observe when the insert query is fired by JPA. We're trying to insert a UUID string into a column that still expects a long, numeric value. That's why we got the data truncated error. The column can't store UUIDs. But that's not the focus. Now open the console logs. First, you'll see this log. Employee Entity Manager repository.saveEmployee, calling EntityManager.persist. Then this one. Employee Entity Manager repository.saveEmployee, completed EntityManager.persist. And now the interesting part. Look at when the SQL insert query actually appears. You'll notice it comes after both logs. That means JPA didn't flush the SQL immediately when persist was called, because it already had the ID value, UUID, so no need to contact the DB at that point. Alright, let's clean things up now. Go back to your employee entity and remove all the temporary changes we made for testing. Okay, now let's test the merge flow. Alright, let's hit the Update Employee API with an existing employee ID. Okay, we got a successful response from the API. Now let's dive into the console logs to understand exactly what happened behind the scenes. First, we see employee entity manager repository.update employee calling EntityManager.merge. That's the log we printed before calling merge. Next, employee entity manager repository.update employee completed EntityManager.merge. That means merge, returned successfully, but still no SQL query yet. And then the SQL appears. What does this tell us? EntityManager.merge does not immediately fire the SQL update. Instead, it copies the changes from your detached entity into a new managed entity inside the persistence context, defers the actual DB update until a flush happens, which could be at commit time or if flush is called explicitly. That's why you see both log statements before the SQL gets executed. Alright, now here's something really interesting and super useful for real-world apps. Sometimes, you don't want to wait until the end of the transaction to run your SQL queries. Instead, you want to execute the SQL right now, maybe in the middle of a complex flow, or right after a merge or persist call before you move on to the next step. So how do we do this? Alright, take a look at my screen. You'll see that Entity Manager provides a method called flush. So what does this do exactly? When you call flush, JPA says, okay, time to push everything I've been holding in memory, all the inserts, updates, deletes, straight to the database. Basically, it forces the persistence context to synchronize with the DB immediately. So whatever changes were pending in memory, they'll be converted to actual SQL statements and executed right now. Flush doesn't commit the transaction, it just syncs the changes with the DB. Call flush method immediately after the merge call. And also drop in a log statement right after flush to see exactly when our SQL gets executed. Start the application. Hit the Update Employee API again. Now watch the console logs very carefully. You should first see Employee Entity Manager Repository.update employee calling EntityManager.merge. Then, Employee Entity Manager Repository.update employee completed EntityManager.merge. Right after that, you'll see the SQL update query fired by Hibernate. And finally, Employee Entity Manager Repository.update employee called EntityManager.flush. This confirms that the SQL was executed right after flush and not delayed until transaction commit. And that's the power of flush, full control over when your changes hit the database. Alright folks, that's a wrap for today's session. Let's quickly recap what we learned. First, we saw that methods like merge and persist don't instantly execute SQL, they just update JPA's internal persistence context. That means the actual database changes are delayed until the transaction commits or something triggers a flush. Then, we explored EntityManager.flush, a powerful tool to force SQL execution right when you want it, even in the middle of a transaction. This gives you full control over when changes hit the database, which can be super useful in complex workflows, constraint validations, or performance tuning. Thank you so much for watching. If you found this video helpful, give it a like. Drop your questions or feedback in the comments. Subscribe to the channel and hit that notification bell so you never miss out, because we've got more exciting JPA and Spring Boot content coming up.